ladies and gentlemen. All right, today we're going to be talking about evaluating inverses and how to deal with inverses. So we're going to be in a couple different parts of your notes packet today. But before we can even get into the inverses, I think that it's important, as I was trying to figure out the best way to approach today's topic, I think it's important that we go back to basics on what we're actually using in terms of the original functions. So I want to flip back for a moment, and you might need to find the back of your cover or just an extra sheet of paper to write this note. I know this isn't super fancy, I just kind of came up with it on the fly, but I think this is going to help you in the long run with today's lesson. So first thing I want to remind you of is that the functions, the main three, if you will, are sine, cosine, and tangent. And the domain, in other words, the angles, are, for sine, you can plug in any angle you want, right? Same thing with cosine, any angle. And same thing with tangent, right? You can plug in you can substitute in any angle you want. Now, generally, we restrict the angles, ourselves to using 0 to 2 pi pretty often, but that's not a requirement, guys. We mostly just do that to minimize how many answers we're going to be looking for, okay? The range for sine, that's what's definitely limited, right? We can't be any smaller than -1 or any bigger than 1. And same thing with cosine. Can't be any smaller than -1, can't be any bigger than 1, right? But tangent, that can be all real numbers. It could be any value. The other thing I want to remind you is that all of these things are ratios of side lengths in a triangle, right? Because remember, really what we're dealing with is right triangle trigonometry, okay? So when we switch to the inverses, remember that inverses undo each other. You could also think about the fact that inverses cause the x and y, or more generally, the inputs and outputs, to switch. That is very, very important. So these two columns, our domain, which represents our inputs, and our range, which represents our outputs, those are going to switch for us in this situation when we talk about our inverses. So I want you to find this page in your notes packet, and I want you to look at this table. So now what once was the range, because keep in mind we're looking at the sine inverse, is now going to be our domain. We can't put in anything smaller than -1 or anything larger than -1. Than +1. We got to be between the ones. That's the bottom line. And then the cosine inverse of whatever we're looking at, same thing, between -1 and 1. The tangent is the only one that is still unlimited, right? Because it's all real numbers for both. Okay, now, here is the challenging part. When we switch our domain and our ranges from the original functions to their inverses, that has effects on the range. Mainly the thing that gets restricted is the range, okay? Because remember that to be a function, every input only has one output. Right? You put in an input, you only get one thing out, okay? So this is where the tables that we filled out earlier become a problem. So I'm going to reference some notes from earlier. So if I look at this table down here of my inverses, you see, if I take a look at the sine of 1/2, let me erase some of this. If I take a look at these problems, okay, so the sine of 210, the sine of 330, and the sine of -30, those all give you out 1/2. Well, when I put in negative 1/2, I can't get out 1, 2, 3 different answers. I can only get one. So what the calculator does and what we do with a function is we always get out the smallest value. So we're going to get out negative 30. Same thing's going to happen with negative root 3 over 2. Of my choices, I'm going to get out the smallest answer. Same thing here. So if you'll notice, all those answers are negative. What ends up happening is that we end up getting, flipping back and forth, a range that starts with negative pi over 2 and ends with pi over 2. Because what the calculator is doing is that even though, and here I'll flip to this right here, even though the sign is negative in the third and the fourth quadrants, it's only selecting the third quadrant because all of those answers are smaller. So we're going to go from negative pi over 2 and then up to pi over 2. So our answers are going to come from the first and the fourth quadrant because this is the one place where we have a positive sign and this is the one place where we have a negative sign. So one of each. Basically, we're not double dipping on any particular value. All right, so now let's take a look at cosine. Same situation. Cosine, negative 1 to 1, but we know that cosine repeats where it's positive and negative. So how do we figure this out? Well, let's again flip back in our notes and let's look at cosine. Okay, so it looks like cosine, let's just pick 1/2. Cosine's 1/2 at 60 and 300. Well, we're going to go with the smaller value. And if we look, the calculator agrees, 60 degrees. All right, over here, we've got 45 and 315. They have the same output, but again, we're going to pick the smaller ones. Now, what happens when we're negative? It looks like we've got negative root 3 and negative root 3 at 150 and 210. Looks like the calculator picked 150, 135. So notice all of those angles look like they're in quadrant 2. So what does that mean for our inverse function? It means that its range is going to be from 0 to pi. Because if you think about it, and again, I know, guys, I'm kind of flipping all over. I'm trying to pull all these different ideas together to make sense. It's because the cosine, let's just think about where cosine's negative again. Even though cosine's negative in the second and the third quadrant, the angles are smaller in this quadrant, and cosine's positive in the first. So these two quadrants together will account for all the places where we have a positive cosine and then a negative cosine. All right, essentially, because we can't double dip, right, we can't have our input give us two outputs. We have to narrow, we have to restrict where we're looking, okay? And so if we think about the tangent is positive in the first and the third, but the first is the smaller angles. Tangent is negative in the second and the fourth. So you might be thinking that it's going to go quadrants. You might not be sure whether it's going to go 1, 2, or 1 and 4. So let's check it out. It looks like the tangent picks the negative values, just like the sine does. So the tangent is going to be in quadrants 1 and quadrants 4. Those are going to be its restricted domains. So what does that mean? That means that the tangent inverse gets evaluated from negative pi over 2 to pi over 2. Now there's a reason why we don't include those two values, and I'll get to that in a second. So here's what this boils down to. If you're using the inverse function and you're evaluating the inverse, your answers are only going to come, remember this is your outputs, are only going to land in quadrant 4 and quadrant 1, and they're going to be negative in quadrant 4, quadrant 1 and quadrant 2, and then quadrant 4, negative angles, and quadrant 1. Now, why aren't these brackets? Well, the sign of negative pi over 2 is undefined. So we can't include an undefined value. All right, now what does this mean for you? What are you actually going to do with this information? Well, for one, it explains why when you use your calculator to evaluate something that's not a famous unit circle value, it'll sometimes spit out an angle in the 4th quadrant, because that's what it's doing when you're dealing with sine or when you're dealing with tangent, right? It's spitting out an angle in the 4th quadrant. What else does this mean? If we are evaluating, if we're looking for an exact value, we're only going to get one answer. So if I look at problem number 1, sine of 3 pi, okay, so that first thing right there, that's going to be 0. Well, what's the sine inverse of 0? Meaning what angle, either in the 1st or the 4th quadrant, has a sine of 0? Well, that answer is just 0. But that's it. There's only that one answer. Some of these aren't going to be very exciting. Some of them are going to be like, oh, duh, that's pretty surprising. All right, but what about this one? Tangent inverse of tangent of 11 pi over 6. Well, the tangent at 11 pi over 6 is going to be negative root 3 over 3, okay? But I can't answer 11 pi over 6 because I'm supposed to pick an angle that lands in the 4th quadrant that's negative. So instead of saying 11 pi over 6, I'm going to say negative pi over 6 because it lands in the 4th quadrant and it's between negative pi over 2 and pi over 2 because of my restricted output. It's all about that output. We've got to have one specific answer. All right, similarly here, we're looking at the cosine inverse, cosine of 3 pi over 2. So cosine inverse of, well, let's see, the cosine of 3 pi over 2, that's just 0. Well, where's the cosine 0? Well, there's a couple of places, but I only want to look between 0 and pi because of my restricted domain. So I'm going to pick pi over 2 as my answer. So again, what this is trying to do is it's trying to get you to understand that when you're evaluating, you're only getting one answer, and so you have a limited amount of places to look. All right? I want you to take a moment and try 2, 4, and 6, and then I'll show you the answers to those. All right, so taking a look at number 2, cosine of 7 pi over 2. Well, that's going to be 0, and then my cosine inverse means I can only look between 0 and pi. So the only angle there that has a cosine of 0 is pi over 2. All right. Sine inverse, sine of 7 pi over 4. All right, sine of 7 pi over 4, that's going to be negative root 2 over 2. All right, now I'm looking for an angle in my interval between quadrants 1 and 4 that has a sine of negative root 2 over 2. Okay, has to be the angle in the 4th quadrant, but remember, the angle has to be like a negative. So instead of being some positive pi over 4, I'm going to make it negative pi over 4 because that would get right there in that 4th quadrant and have a sine of negative root 2 over 2. All right, last problem to take a look at on this page. Cosine inverse is going to be of tangent of 3 pi over 4. Well, that tangent is negative 1 because I'm in the 2nd quadrant, so I'm negative. And the cosine of negative 1, I need to look somewhere between 0 and pi. Well, luckily, pi is in my window, my interval of outputs. So that would be my final answer. All right, hopefully that makes sense, guys. We've got some more practice problems for you on an earlier page, these right here. I do want to point out there is some archaic notation. If you see arc, that's like an old school way of saying inverse. So if you take a look at like problem number 2, it's really just asking you for the sine inverse of negative 0.75. All right? Now, for some of these, you may need your calculator, but not for all of them, okay? So if possible, you want to try and keep things as like exact as you can. I would say that your calculator is going to be needed probably for problems 1 and 2. I would say you need to think about your intervals for questions like number 4, 5, 6, 7 and 9. And then I think you're going to need a triangle for 10 and 11. Ooh, and I think if I'm looking at it more closely, I think you might need your calculator for 3 and maybe for 8, but you might see something nice happen in problem number 8. So calculator for the ones I just circled in orange. These are no calc, the ones in red. And the ones in purple, you're going to need a reference triangle. The answer key is going to be posted for you guys, so you should be able to check that out. All right, we will do more practice. No worries. All right, I hope you guys have a good rest of your day. See you soon.